Welcome. I'm Bill Wake. This is my weekly summary of the work we've done on Twitch. Lately, we've been working with a language called Tenth that's an imitator of Fourth. We developed the compiler and interpreter for it, and this past week we've been focused on making a demo project, which is going to be a hangman game. All right, so we'll go through most of what we have so far for hangman. We have game init, game display, game loop. We'll look at the tests for that too. Game over. A couple of things to update. So update clue and update wrong guess, and then finally draw head. We haven't got the part about the body working, but most of the rest is kind of in place. All right, so game init, we're going to just set up some state for the thing. So what you pass into this is the word that you want to make the puzzle out of. So 309 there, it initializes the wrong guesses. So that's a list of the mistakes you've made, and we clear that list out. 311, we're going to make an extra copy of the string, and then swap it with the answer, which is another structure that's holding. It's going to hold the answer itself, and string to array converts it. So it comes in as a string, and string to array turns it into an array, the answer array, and that's easier for us to work with. All right, then we're going to create the clue, and the clue is the underscored lines that you get for the initial guess. So if it's a 6-letter word, you get 6 underscores. And we take the length of the string, the array and length, we take the length of the string, then we put the clue on the stack, and 95, which is the underscore. We don't have a facility to introduce character constants yet, but if you call repeat dollar on that, it fills the clue array with that many values of underscore. So exactly what we want. Now, I don't know if you've seen fourth before. I guess I'll comment a little on what we're doing. So colon in 308 says open a definition, and then 320 has the semicolon that closes it. So this is a definition of game init. And the other thing that I do almost always, at least for anything of any length, is I keep track of the stack contents, not the values, but just kind of the structure. So this thing comes in with one string. 311, the Duke creates 2 strings on the stack. 312, we have the string, the answer in the string, and so on. So I'm always keeping track of those because, well, if you don't, you get very lost very quickly. All right, let's go on. So game display is really just the pure display. There's no logic in it other than how do you draw. So we clear the screen, we draw the title, which is Hangman. We draw the clue, which starts with those underscores. Then we draw the scaffold. And then we don't yet draw the body parts. We draw the wrong guesses. So we have the phrase wrong guesses and then the letters that you've guessed and a few new lines to make some room. All right, so this isn't so bad. Sometimes I feel like I'm writing assembly language again. All right, now game loop is kind of the main piece of getting this game going. And this is what we finished. I'm showing this a little out of order as far as development because we just worked on this yesterday. But the heart of it is I'm going to just highlight certain lines. So 393 is the while. So game over not. So while the game is not over, we're going to do some stuff. And then in that loop, the real thing is we call the character read, which is line 398, and then we update the clue. So if they guess a letter and it's right, it goes in the clue and replaces the underscore. And so update clue returns a true or false depending if it found anything to update. So basically if it's a right answer or a wrong answer. So the first case is, well, if it didn't find anything, then we update the wrong guess. So we add the letter to the bottom where you list the ones that you failed on. Otherwise, we pop. And the pop is there because we need to make sure that both exits from the if statement end up with the same stack, or at least stack structure. So Our if after the update wrong guess has read and display. Our else comes in with character read display, so we pop that character, so we end up with read display. And then at the bottom, we are calling the display in 409. So we've passed in a couple of routines to this thing for starters. So the read routine and the display routine, because those are the IO bits that I want to stub out. And using this call instruction is what gives me that stubbing ability. It takes a string, the name of a function, and calls it. It's if you don't have that, every test kind of from the as soon as you start anything with IO, you're going to have tests with IO in them and no way to substitute out. So this provides a primitive method for that. I mean, nothing guarantees those strings are actually procedures, so there's a little looseness around that. But the heart of this thing, though, is while game not over, update the clue. If the clue came back as a failed clue, then update the wrong guesses. Otherwise, pop and make it ready for the next thing, and then display it. So while game not over, read a character, update the contents, call the display. That's a nice a typical game loop, I guess I'd say. All right, and now let's look at how do we test that game loop. All right, and I don't think we have perfect tests for that, but it's got a loop dependent on character input and on getting right answers and stuff. So it's got some challenges to it. All right, so 207, we're going to create an array called read stub array, and this is going to hold the characters that we're going to simulate typing. In 211 there, you can see we do a string to array, so we convert that string to an array of single characters. And then we have the read stub index keeps track of which character is next, and it starts at 0. So read stub is the routine that gets called instead of get character, we call this to get the character. So, even this small thing would kind of benefit from indicating what's on the stack, wouldn't it? All right, so read stub array, we push the array on the stack, we take read stub index and at, that gets the contents of the variable, and then at plus basically says, give me the contents of array sub read index. And given that contents, we're going to have that on the stack, and then we'll update the variable read stub index so we go on to the next one the next time. Okay, and so as we need characters, this thing will provide it. And then finally, 221 there, we have display stub, and it's just an empty method. We're not going to do anything in the test version. We trust our display routine to display things. Okay, and then the test itself. So 225, 90210, what's that? Well, one of the mistakes I found that it's easy to make is not clean up the stack properly at the end. And so what you have looks right, but you've left some garbage on the stack or something like that. So the tests, almost all my tests now, push some, not random, but arbitrary number. And at the end, there's 90210 assert equal. So we're making sure that the stack, after I do my assertions, the stack is back where it started, and that we haven't either trashed the 90210 or left stuff on the stack or anything like that. All right, so the arranged part of this, AA, game init. Well, if you do crossword puzzles, you probably know is a kind of lava. It's a very nice short word. So that's our answer. And then our guesses, we're going to first guess B and then guess A in our read stub init. So the work we did to set that stub up, we'll have an array of characters, and we can pull out the next one. Then 229, we're passing the display stub and the read stub. So those are quoted names of routines, and they're the arguments to game loop. So that's the act part. We're going to call game loop with those things. And then at the end, we'll turn clue. Clue is an array. We'll turn it back into a string with make dollar and make sure that they got the right answer. And then in 232, we're going to check the wrong guesses array and make sure that the wrong guesses are recorded. So we did B first. That's not in the word and we'll make sure that's there. And sort of implicit thing here is that the game loop terminates when your clue equals the original answer. So as you substitute those underscores with letters, correct guesses, eventually you get the right answer. Okay, now the real game, we haven't done this yet, but it should also check and make sure that you don't have too many wrong guesses. So the hangman part we're doing lets you make 10 guesses, and we haven't restricted you. So the way it is now, it could take you 20 guesses to get it right, and the only way to get out of the game is to guess the word. All right, so here's that game over, and it's really take the clue, make a string, take the answer, make a string, and make sure they're equal or not. And if they're equal, the game is over. And this is the place that will get some more attention as we kind of do the next version of the game with checking the number of answers. All right, and so in that loop we called update clue. This is a bigger piece than I like, but it's kind of on our list to refactor. But I'll walk it through anyway because I think it's kind of the heart of the game in a way. I mean, the game loop's important too, but anyway, we have a clue index, so that's just a variable that we're going to use as a counter, and we're going to keep a result on the stack. So at first, we assume you haven't succeeded in guessing a valid character, and so we push a 0, which represents false, and we swap it so the result is on the bottom of the stack, or at least the bottom of the stuff we're looking at. So we have the character that comes in, and then we have the result. Okay, and so what we're going to do is go through a big loop to make sure does this character occur in the answers, and then everywhere it occurs, we're going to add that to the clue. So the answer is the correct answer. The clue is the underscores that accumulate letters from the answer as you do it. So any position in the answer that has that letter should get the same position in the clue to fill in that letter. The split we've talked about is to break up looking for a match from mapping all those letters. Although, I don't know, it's going to be so similar, it may not be worth breaking up. But I'll go back to the game loop for a second. So notice we had 403, we have update wrong guess. 405 is just a pop. Well, from a symmetrical point of view, it would be nice if one way had update wrong guess and the other had update right guess. But we do that in update clue, and also as a side effect compute whether or not it was a good guess. So that notion of doing something and computing the side effect is what makes me want to split it up. But I also know that most of what it does to figure out the answer is stuff you'll do in the side effect too. So it's tough. Okay, so anyway, the loop, we'll go through the answer, and we're going to look at the index. We're going to work our index from the first letter to the last, and basically try and figure out if that letter appears. Okay, so first we're just making sure we're not at the end of the word. Okay, so the while loop is over the words, and you're comparing the character at the current index to 0 to tell you that you're at the end of the word. Okay, so while you're not at the end of the word, come in here, and then we have the character, we have the character at 364, we have character answer, character, and result. And then we're going to swap things around. BAB pulls the second item, a copy of it, to the top of the stack. So we'll have CH and CH answer, and we'll try and decide if the answer's character is equal to the character that they guessed. And if so, then we want to put it into the clue. If it's not, we just want to move on. Okay, so the put it in the clue part, if they are equal, then we're going to duplicate that character so we can we don't want to lose track of the input character. And then the 369, we'll take the clue and the index, and we'll swap things around so that we get the order. We want the clue we want the value on top, then the index, then the clue. and at plus equal needs them in that order. So it assigns the clue character at the position that we found it in the answer. Okay. And once we do that, we're just swapping things around in 370 there. We're trying to get the result true because we did make a good replacement. So we should record our result, and swap pop brings the old result forward, deletes it because we don't care if it was 0 or 1. We just want to make sure we get a 1, and then swap puts it back as the second entry. And we came into the if with ch and result, and we exit the if with ch and result. So we don't need an else clause to balance things out. And then at that point, we just increment the clue index, go back up to the top of the loop, and look at the second character of the answer and decide if that's a match. All right, now when we exit the loop, we have the character answer, the character, and the result on the stack, and we just want the result. So we do pop, pop, and we end up with the result. All right, this is kind of as tough of a routine as I want to write. Any deeper than this, I definitely need to be calling other routines to do some work. All right, now update wrong guess. That's for the case where they guess something that's not in the clue, they guess something not in the answer. So it needs to go in the list on the bottom. Wrong guess is basically 382 is setting up so we can write the next wrong guess. Okay, so wrong guess's index keeps track of the position to write the next wrong guess. We'll swap things around so our at plus equal can make the assignment, and we'll move the wrong guess's index forward so we're ready to write the next one next time. So test draw index in 474, we have a spy we're going to call test draw spy. I'm not going to show that code because it's the thing that produces that string in 479, the 140 tilde. It needs somewhere to write that. So test draw index basically resets the spy's drawing area, so it writes the value there. So test draw spy is not going to draw a picture. It's going to capture the row, the column, and the first letter of the output. Okay, and for each draw command. All right, and so we're going to put 476, the actual test part. 1, 2 is row 1, column 2. So I'm drawing. Basically, I'm going to give these draw routines. Pretend there's a bounding box drawn around, like from the head to the feet, and left and right. We're going to make that little bounding box. 1, 2 is going to be the top left corner of that box. So it'll be the row that the head is in, and the column that the first hand is in. Okay, and so each routine will take that address and the routine to use to draw it, and then draw head is supposed to do the drawing. Write a 0 at the end of the string, and then we call 479, we call test draw area make $, turns that area into the string, which should be 140, and make sure that it is equal to that. So it's capturing those arguments. Now the 1 is the one that we pass in 476. The 4 is because if you started in column 2, that's the column with the hands and feet. Column 3 has the arms and legs, the first ones, and then column 4 has the head. And so that's why it's a 4. So it's adjusting that coordinate to the actual coordinate it's going to draw to and the character that it's drawing. All right, so given that it's done that, we know it adjusted the column and row right and drew the character we expected. And so if that's good and we haven't messed up the stack in 481, then we're going to say we've done the right thing. So our plan is we just got the head drawing done at the end of the session, the last session. So our plan is to get the other drawing characters done, and then we're going to maintain some sort of list that tells you if the first time you get it wrong, draw head, second time draw left arm or left hand or torso, maybe whatever's next, and we'll build up an array of those. And that way our routine we're testing is, do you draw the right thing? Not, we don't have to go back and verify the actual drawing stuff at the higher level. All right, and then the draw routine itself, well, we swap row and column around because we want to manipulate column. We're going to add 2 to it, and we're going to put the string on top, O, the head character, and then BCA kind of swaps the stack around into column, row, and string. And then our draw routine, that's the order it expects its arguments, and so we call that routine name. So in production, that's the actual draw at method. In testing, it was the draw spy or whatever we called it. Okay, so we've got to start. All right, so now let's do a demo. So to run the demo, the code we're going to use, we'll take calculus. That'll be our answer. And we'll call game init with that. So that sets up the game. Then we'll call game display to show the initial state. And then the last line, we're passing 2 string arguments to game loop. So we're giving it the display to use, the display method, and the read to use, the get character. And in game loop, that's what we'll need those strings. We had tests, the test used a different, a stub for those, or yeah. And now we have the real code. Over here, I imported the code for what we have so far, and we'll run this code. I'll just paste. Okay, calculus, game init, and so on. All right, so we can see it's a 8-letter word, if I counted right. We've got the gallows. We haven't done any drawing yet. Well, you wouldn't anyway at this point, but there's no wrong guesses, no body parts. Okay, so let's make a guess. H, all right. We accumulated a wrong guess, but we're not drawing body parts yet, so nothing else happens. M, A, L, C. You can see it's coming along. All right, so coming up, we need to draw the remaining body parts for wrong guesses. We got to do something that chooses which parts to draw. And at that point, the game should basically be done. We may have some tweaking or some things to do for it, but at least version 1, that's all we're asking for. And I want to go back in at the lower level. One of the things we know is we don't do any bounds checking on array assignments. And we had at least one time where we wrote something. Well, we treated a variable as an array and accidentally overwrote some code, so that was rather inconvenient. But we know a way to do bounds checking. I'd like us to put that into the interpreter level. And then we have some other refactoring we might want to do with the interpreter, compiler and interpreter. And then I'll do a little assessment of the whole project. We're very close to the end. All right, so if you want to join us live, Monday to Thursday, 2 to 4:30 Eastern, or 6 to 8:30 p.m. UTC, except this week I'm traveling Wednesday, so only Monday and Tuesday, but I think that'll be enough to do what we want to do to finish up the game and finish up the project for now anyway. If you want to go to the live sessions, xp123.com/Twitch will take you there, or you can look at the time-delayed older sessions, xp123.com/YouTube. They're delayed about 2 or 3 weeks and lightly edited. All right, well, thanks for joining today. Hope I catch you sometime at our sessions. Bye-bye.